My name is Ethanoid, and today we'll be continuing a series in organic chemistry. And today specifically, we'll be talking about functional groups. But before that, I would do a continuation and I'll do an explanation of a previous video of mine, which I talked about the hydrocarbons, alkanes, alkene, alkynes, and benzene. So, and I also touched a little bit about benzene derivatives in the previous video. You can check it out in the organic chemistry one. So now today I'll be doing a prerequisite explanation for you to understand functional groups. Now, carbon is just like an atom that can carry a maximum of four other substituents. So, and those substituents can be anything, and it can be hydrogen, it can be any other item, it can be nitrogen, it can be oxygen, it can be sulfur. So, but a maximum of four attachments, and those attachments, they are called bonds. So carbon is an atom that has a maximum of 4 bonds. So after 4 bonds, carbon cannot carry any other bond. So carbon is just like something like that has 4 bonds outwards. Now I want to explain saturation and unsaturation. Now when all these bonds, all these bond arms have been attached to some other atom, then it's called a saturated compound. So if all of the bond arms are already attached to something like hydrogen, nitrogen, or oxygen, but if it's attached to oxygen to be a double bond, oxygen always has a double bond because oxygen always has two lone pairs. So if it is oxygen to be 2, but if it's hydrogen it will be 1. So we have H, we have H. So basically, for something like this, it is called a saturated carbon atom because all of the bond arms have been attached to atoms. But when you have only 3 and one is left empty, then it is called unsaturated because one arm has not been substituted with or has not been attached with something else. So that is how saturation and unsaturation works. So because of that, you will be able to understand functional groups now. So in this video, we're talking about functional groups, and there are different types of functional groups. And the first one we're talking about is the phenols. Let's talk about phenols. Now phenols, because the last video I stopped at benzene, right? So phenols are a derivation of benzene. So phenols, let's talk about phenols. Phenols are formed from benzene rings, but in those benzene rings you have an OH attached. So OH. So this is the general structure of benzene ring. So in those benzene rings, and whenever you have an OH attached, it's called a phenol, and they always have their names always end in PHE and OL. That's the phenol group. So whenever you have an hydroxide that radical bonded to a benzene ring, it's called a phenol. Now the next one we're talking about alkanols. So alkanols are basically derivative of the alkene series, and they are formed whenever you substitute one or more hydrogen with a hydroxide bond with or hydroxide radical. So it is something like R. When you substitute one of the hydrogen with a hydroxide radical, so they are similar to phenols, but these alkanols, they are formed with alkyl groups. So they are substituents of alkyl groups, while phenols are substituents of benzene ring, but alkanols are substituents of alkyl groups. And what that means is that when you call something a substituent, it is attached to something. It is not the main part of something, but it is an attachment. So this OH here is called the attachment of this R, and this R is an alkyl group. Now that R could be CH3, could be C2H5, ethyl group, should be methyl group, ethyl group, propyl group. So all these are alkyl groups. So alkyl groups are basically formed from alkane when you remove one of the hydrogen atoms. When you have something like methane, CH4. If you don't understand what methane is, you can check the organic chemistry 1 video of this channel. So I explain what alkane and how the homologous series are formed. Now, when you remove one of these atoms and make it CH3, that is called an alkyl group, and that alkyl group is specifically known as methyl group. That CH3 is methyl group. Now, this R could be a methyl group, could be an ethyl group. So that ethyl group is something like C2H5. So that's an ethyl group. So and we have propyl group, we have butyl group. So all those ethyl group, whenever you have one hydrogen, and that hydrogen that is substituted, it is not left vacant. So a hydroxide group is sent in to replace it, and that hydroxide group is known as OH. So anytime you see OH, it's called an hydroxide group or a hydroxide radical. So this ordinary H is a hydrogen group or hydrogen atom. So I hope I've explained how this substitution works. So and the names of these alkanols always end in OL. So their names always end in OL. So now the next one we're talking about is alkanoic halides. Now these are formed when you have a carbonyl group and a halide. And a halide is basically a group 7 element. Something like chlorine, fluorine, bromine, iodine, aspartame. They are all in group 7. So and basically when you have an alkyl group and you have a C R, you have that alkyl group, something like CH3, CO, CH3, you have CO, COCl. Now this is an alkanoic halide. So you have this is called ethanoid chloride because it has 2 carbon atoms. So the carbon atoms, the name of the substance is determined basically on the amount of carbon atoms. If there's 1 carbon atom, it's called a met. It's called methanoid halide. If there was only 1 carbon atom, it's called methanoid halide. I'm not sure that exists, but if this is 2, as you can see, this is 2 carbon. So 2 stands for earth, 3 stands for probe, 4 stands for boot, 5 stands for pence, 6 stands for hex. So those are names you should be able to cram, and I will also add them here at the end of this video, probably in another video, so that you can be able to understand how all this works. So now this is called ethanoid chloride, and the general name is OYL, oil halide. So these names always end in oil halide. Like this one now is called methanoid chloride. So now if you have chloride, you substitute instead of halide, you just say chloride because specifically it's a chloride. So it's a substitute. That chloride is a substituent. It has been substituted in. So next we have other examples. We also have alkoxyalkanes. Alkoxyalkanes. Now this alkoxyalkanes is formed when you have an alkyl group, then you have an oxy, then you now have another alkane. So and this R could be the same as this or different. So now that R is just like ethoxyethane. Something like you have CH or let me give you methoxyethane, CH3, then you have an O, then you have C2H5. So this now, as I explained earlier, this is called the methyl group. Why? Because you have 1 hydrogen atom substituted or removed from methane. So anytime you have a hydrogen atom removed from methane, it's called the methyl. Now this is a methyl group, and then you have this an ethyl group. Why? Because you have an hydrogen atom removed from an ethane. So anytime you have an hydrogen atom removed from an ethane, it's called an ethyl group. Then you have an oxygen atom connecting them together. That's why it's called an alkoxyalkane. So their names also held in oxyalkane. So that alkane will change depending on the specific alkane you are given. So like if it is ethane, then you call it alkoxy ethane. So this one is basically so it's basically, let's remove this oxy. So yes, you can also call it oxy. Yes, let me put it back. So you can this called methoxyethane because instead of alkane we know specifically that it's ethane. But if this was C3H7, this will be methoxypropane. Understand? So that is another functional group. Next on our list, we also have alkanones. Now, 5 alkanones. Now, alkanones are functional groups formed when let me give this example. Alkanones are formed when you have a carbonyl group, and the carbonyl group is basically a combination of carbon and oxygen atoms. That's called a carbonyl group. So now that's a bond between carbon and oxygen when it's attached to an alkyl group. It's called a carbonyl group. Now that carbonyl group, it is formed in this way. Alkanones have the general molecular formula R C. Then this is called the carbonyl group. Then you can have RCOR. So this is the general formula of an alkanone. So basically, these alkanones, the R might be the same or might be different. So this RCOR is called an alkanone, and their names always end in O. So if this R is if when you add the carbon atoms in this R and you have 2, it's called an ethanone. Then you have a propanone, you have butanone. So it depends on the number of carbon atoms, but they all end in -one. So that is the functional group for the alkanones. Then next we have alkanoic acids. So let's look at number 6, alkanoic acids. Now these alkanoic acids, they have the general molecular form RCOOH. So this is the general molecular formula, and the structural formula goes like this: your R is formed to your C, then your C is double bonded to your O, and then you have a single bond to OH. So as I mentioned earlier, your O is always double bonded to your carbon because O has two lone pairs. So it has 2 bonds that can be bonded to the carbon, but this O is only one available electrons that can bond. So next we'll be talking about other properties of this kind of element, this kind of functional group and their homologous series. But today we'll just list out what they are. So and this RCOOH or RCOH, you can use any structure you want. Now this is first one or the second one. So this is basically the alkanoic acid, and their names always end in OIC, oic acid. Then next we have the acid anhydrides. So and basically an anhydride is basically something that you have removed some amount of water. So basically when you have 2 alkanoic acids and you remove a mole of water, you form an anhydride. So basically it's formed from 2 alkanoic acids. When you have RCOOH and you have RCOH, then you remove OH and you remove H from one. So you have C, O, then you have O, then you have another C, you have R, then you have it bonded to your OH. So basically this is how it looks. So you have 2 alkanoic acids come together to form this. So when you remove one mole of water, so basically that's how it's formed. And then this is, you also have a hydrogen atom. So that's how they are formed. So I guess that's us. We'll move on to the next one. We'll talk about alkanoid halides, right? We'll talk about haloalkanes. I will talk about haloalkanes. No, we'll not talk about haloalkanes. So haloalkanes are formed when you have an ordinary halide that is substituting a hydrogen. So let's call that haloalkanes. So in haloalkanes, we have something like RX, directly to X. So basically their names also end in alkane. But as I mentioned earlier, these acid and hydride, let me go back to them. Their names also end in alkane. Their names also end in oic acid, just as your alkanoic acids. So both your alkanoic acid and your acid and hydrides, their names both end in OIC acid, that's oic acid. So these are the basic functional groups that you need to know for your examination. And then we also have some other functional groups like the amides. Then we also have the alkanones, and we have alkanals too. So let's talk about alkanals. Before we run all this video, let's talk about alkanals. Let's make it 10. So alkanals. So alkanals are formed when you have your alkyl group and it's formed to a carbon, to your hydrogen, and then that carbon is bonded to an oxygen. So that's how your alkanals work. So that's the general formula for your alkanals. So basically, I forgot to include that this is actually an oxygen. This actually is bonded to an oxygen. Yes, so it's bonded to an oxygen. You have the substitution, and then you have an oxygen bonded. So those 2 hydrogens that were before, like when you have an hydrogen, this OH, it has been removed. So you remove a mole of water from 2 acids. So that's how an acid anhydride is formed. So I'll just go back to revise that. So we have haloalkanes, that is when you have an R to X directly. Then you have your alkanals, that's RCHO. And their name end with AN. So lastly, number 10, we'll talk about the amines. So now amines are like a substitution of your carbon atom. Then you have nitrogen. So when you have your nitrogen atoms, then you know your hydrogen, nitrogen has 3 bonds available for other atoms. So but carbon has 4. So when you have anything amines, it always has 3 bonds. So you have one like NH, C with NH. So this anytime you have H and H and H, it's called a amine. So this kind of amine, they have 1 nitrogen, and then they have 2 hydrogen, and then one of the hydrogen. When you have substitute one of the hydrogen, with an alkyl group, you have a primary amine. But when you substitute two of the hydrogen with an alkyl group, you have a secondary amine. If we remove another H, I will turn it to R to be secondary. Then we will remove the third and turn it to another with tertiary amines. So these chemical compounds, these organic compounds, they all have their properties. And these ones, lest I forget, amines, they end in amine. So you have something like methylamine, ethylamine, and others derivatives. So these names can become complex when you have different radicals and substituents coming together. But this is meant to be an introductory video. So later on we'll look at these ones in details one by one, and we'll talk specifically about them. But thank you for watching and good luck.